Welcome to a video on measurements again, measuring area and volume this time. In this video we're going to try to understand how to use square units to measure area, and then use dimensional analysis when we want to change units from one unit to another, and then cubic units for volume, and then be able to go between the English and the metric units to measure capacity, which is basically like another name for volume, and the metric version of those units that we're familiar with. Alright, measuring area. A square unit literally is a square, and each side is whatever that base unit is. So there's one square unit, arbitrary, just a unit on the left side and a unit on the right, and a unit on the top and a unit on the right. And then if we specify the unit, a square inch, a square centimeter, then that literally is what that sounds like. It's got an inch on every side of that square, or a centimeter, or a foot, or a yard, or whatever it is, the base unit that we're putting on each side. Alright, so what's the area of that region? Well, we can count one by one, or we can just think of it like multiplication. This is 4 this way, it's 3 up, and 4 times 3 is 12. So there's 12 square units, right? Or literally you can just count. Each one's a square unit, you just count it. Now, if we take our conversions that we did earlier for distance, and we apply them to these square units, we have to be careful, because 12 inches is a foot, but 12 square inches is not 1 square foot. We literally square these things. Like 1 square foot is a foot by a foot, so there's a foot in both directions. So there's 12 inches in both directions, and because of that we end up with 12 times 12. Remember, area of a square is length times width. Squares are just rectangles, so we have to multiply the two dimensions together. So a square yard is 9 square feet, not 3 square feet. So we have to be really careful when we are converting square inches and eventually cubic inches. It's not the same thing as when we did it before. Okay, we literally are squaring these things. So 12 squared is 144. 3 squared is 9. Right? 1 acre, that's a square unit as well. It doesn't say the word square in it, but it is a common unit used to measure how much land, how much land we're dealing with. And you can't measure land in just one direction, so you have to have two, and that's what we're talking about when we have these square units, is we have length in 2 directions. Okay, an acre is about 43,560 square feet, or 4,840 yards, square yards. All right, and then a square mile, that's 640 acres roughly. Alright, here's an example of using square units to compute population density. So after Alaska, which is way up there, getting up in the Arctic Circle parts of it, Wyoming is the least densely populated state. Population is 568,000, just over that, and the area is a pretty big state, 97,814 square miles. What's its population density? Well, population density is population divided by area. So we're going to take our population, we'll divide it by the area, and that's what we get down here. Now we round this thing, typically make sure to pay attention to where they tell you to round it. Sometimes they, like in this example, it says 10th place, but sometimes they'll use hundredths place. So just pay attention into the problem if you're doing your homework, and round appropriately. So all we're doing is just plugging those two numbers in, and we're seeing what it gives us. So 568,158 divided by 97,814, and that's where that 5.8 is coming from. We're just taking that number and rounding it to the nearest tenth. Alright, so there's some English, or US really, this is now basically just the United States measurement system now. But the square inches, the 3.5 square centimeters, that's coming from the 2.54. If you remember in the unit section, it was 2.54 centimeters was an inch, and if we square that, we get the 6.4516, and they're rounding that to 6.5. Alright, so square foot, 0.09 meters, square meters, and square yard, about 0.8 square meters. These are just the if you go back and look at your notes in chapter 9.1, it's the same thing. It's just that we're squaring these things because it's area. Alright, so let's use dimensional analysis for units of area. So a property in Italy is advertised at $545,000 for 6.8 hectares. Find the area of the property in acres. Well, we just go back. This is the unit that we're dealing with, so we're going to start with that, and then we're going to use, because we're starting with hectares, we are going to use this one down here because we want to go from hectares to acres. It's just we want to make sure that the units offset, so that hectare has to be down in the denominator when we create our unit fraction. Okay, so remember we want to put those two things that are equal or equivalent, one over top of the other. Alright, and it's just who goes on top and who goes on the bottom depend on what your measurement was. Whatever your original measurement was, when you set up your unit fraction, it'll always be in the bottom, just like it was in the last section, and how it's going to be in the next section. All of chapter 9. Alright, and because we have a number in the denominator that's not 1, that means we will divide. So 6.8 divided by 0.4 is about 17 acres that we end up with. Alright, what's the price per acre? So just take that 545,000, divide by 17, and that gives us a price of about $32,000 an acre, a little bit more than $32,000 an acre. Alright, now volume. Volume is 3 dimensions. So area is 2 dimensions, and so we had square units. But volume is 3 dimensions. So we start off with that square on the face, but then we go back another dimension beyond that. So that's where we get these cubic ideas, cubic feet, cubic inches, cubic centimeters, or cc's, what you commonly hear those as. So that's literally a cube. A cube is just a three-dimensional object where each face is a square, and all those faces are, like any other square, the exact same size on each side. Right, and it's just like that all the way around. There's 6 sides. All of them are squares, and all of them are perfectly the same. Alright, what's the volume of this solid? So there's a cubic unit. Now we have to think about this. Just like we did before, it's easiest to just multiply this, count it up. So we have 3 going this way. We have 3 going this way. And then we have 2 going up. Right, and the volume is going to be for these solids. The volume is length times width, which is the old area formula for a rectangle, but then we multiply by the height. So length times width times height. So we got 3 times 3 times 2. 3 times 3 is 9 times 2 is 18 cubic units. Alright, and you can think of it that way. You can literally count these, but because it's 3-dimensional now, you got to remember that we can't see everything. You gotta it's what this is illustrating down here on the bottom, is you gotta think of things not being there, like that bottom row being like the bottom of this thing being a repetition of the top. So I can count there's 9 things on the top, and then there's a second row of this underneath it, so that would be 18. So you gotta be careful when you're trying to just count it. That's why I say the easiest thing to do is just to multiply to get these. Alright, capacity, that's just another way to say how much fluid something can hold inside of it, or not necessarily fluid, just how much space it can hold in that 3D object. typically we think of fluid just because it can get into every nook and cranny in the object, but it's just how much of that fluid it can hold total. It's a 3D idea. All right, these are our US values that we're used to: cups, quarts, gallons, ounces, and there's the basic units in there. Pints are also very common one. There's 2 cups and a pint. I don't know why that got left off of there. 2 cups equals 1 pint is another very common US unit. And then here's some of the ones that are maybe not as well known as this top group here. These down here, cubic yards. That's a lot of times like landscaping supplies are sold in cubic yards. Cubic foot. If we're talking about, all right, I've got a 2 by 3 by 1 box. What would that be able to hold as far as liquid? So liquid, we typically think gallons and pints and quarts. So we're going from like distance units with these to what we typically think of with capacity over here on the other side. So that's what that bottom area is for. It's for the atypical units that we are typically we don't see very much when we're doing capacity and volume type problems. Alright, but let's try one. So a swimming pool has a volume of 22,500 cubic feet. How many gallons? So it's going to be the one down here on the bottom that equates gallons and cubic feet. So we're going to use that one. Again, we're given how many cubic feet it is, so that's going to be on the bottom, and that 7.48 gallons will be on the top when we set this thing up. So there's our unit fraction, and we set that up. The cubic feet cancel, and we're left with all ones in the denominator, so that means we just multiply to get our answer. So after we multiply, we see it's about 168,000 gallons to fill up that pool. Alright, metric system, just like we talked about in the last video, that we were going to go through and take this King Henry died by drinking chocolate milk and apply it to different types of measurements. So we did length in the first video. Now we're doing capacity. And so instead of meter, we're using the liter as our base unit. But everything else is the same. There's my base unit. When I go up, I'm getting into more and more and more liters. Everything's by powers of 10. So 10 squared, 10 to the third, that's 1,000. And then when we go down, we are getting smaller units. So 1/10 of a liter, and then 100th of a liter, and then 1,000th of a liter when we're down there at the milliliter. Alright, these are the ones that you see the most. Alright, the milliliter and the liter. But occasionally, if we're talking about something fairly large, we'll get into kiloliters, sometimes. But liter and milliliter are the ones that we see the most, because that's what we see in a grocery store, at a vending machine. All right, cubic units in that deal with length, like centimeter, centimeter, centimeter. Again, in the metric system, the conversions are just so much easier. The numbers are just so much nicer. If you look at what they were before, it was 200, 7.48, 231, and now it's just 1 to 1, 1 to 1, and maybe 1 to 1,000, depending on which one you want to use. So 1,000 cubic centimeters or 1,000 cc's is a liter. 1 cubic centimeter is a milliliter. 1 cubic meter is a kiloliter. It's just nicer numbers to work with in that metric system. Alright, let's look at one with the metric system. So, aquarium has a volume of 36,000 cubic centimeters. How many liters of water would that take? So, again, back on this last page, we've got 36,000 cubic centimeters, and we want to know how many liters. So from this page, that's this one right here. 1,000 cubic centimeters is a liter, so we use that unit fraction. The liters cancel. There's 1,000 down there in the denominator, so that means we are dividing. And so we just divide 36,000 by 1,000. I'm left with 36. Okay, so the next video, we're going to see something very similar. It's just the biggest thing that you're going to need to get through all of these videos is just that offsetting a unit fraction, where you want that denominator to have the same units as the original measurement, so those measurements will cancel.